Okay guys, so this is part two. We're just going to get right to it. What we're going to do here is just keep working out the example that we have of this function. But now we're going to find the secant and the tangent of this function. So let's use a different color for that. Let's stick with black. Don't want to confuse you guys. We'll use red for the tangent one. So what we're going to do here is let's do the secant first. We start by following just the formula that we have, which is f of x plus delta x. So this is our f of x. For the x value, we're going to plug in x plus delta x, which would be x plus delta x squared, correct? Our function is f of x squared, minus just f of x. F of x is just x squared. So, and we keep moving along, all over delta x. Once we solve this, the x term, I'll do it for you guys one now. Plus 2x delta x. This is just expanding right here. Plus delta x squared minus x squared, and all over delta x. Now this cleans up nicely, right? X squared minus x squared cancel out. And one way I can promise you guys to verify if your answer is right, the terms that you have left, they should all have delta x. There shouldn't be any terms that don't have delta x. So we know that this is correct in this case because this term is left and this term is left and they both have delta x. So we could say, okay, this is 2x delta x plus delta x squared all over delta x. And there's a common factor here, delta x, delta x, delta x, and we don't need to make that line. So our final answer is 2x plus delta x. And that is our secant line. So this will define the slope of the secant line for this particular function. But now we're going to work out the tangent line. Now we could just apply the limit to the secant line and call it a day. And pretty much that's the idea here. We don't need to do all this work again and just apply the limit, because m of t, the secant line, is just the limit as delta x goes to 0 of the secant. And we have the secant, right? Here's our secant. We know this is it. So let's apply the limit. Oops. Actually, it's fine. We have more space. The limit is delta x goes to 0 of 2x plus delta x, which is 2x, and delta x is 0, plus 0, which is 2x. So this is correct, and it's theoretically we know this is right because our tangent line is linear here, and this describes the line right here. And whatever point this is, you can find out if you just plugged in for the corresponding x. But later on, you're going to understand that you don't need to do this every time to find the derivative. You just simply, we're going to use different techniques, and you guys will be able to verify that this is totally correct.